And we are live. Welcome to Dividing Decimals with Doug. That's what this is. There's no dog with me. It's not Dividing Decimals with Dog because the dog is doing her job for someone else. She is my beautiful assistant, but she has other uses because somebody upstairs is sick and needs heating pads. So the heating pad that goes in the microwave is behind her back, and the heating pad that is furry and cute and runs around is sitting on her lap, keeping her warm. So Mocha is very pleased and proud to be able to provide that service to the bunny rabbit upstairs, and I just have to teach my math lesson without her. This is the Hurricanes, that's a rugby team from New Zealand, and with that I will get into the math. Okay, dividing decimals. Well, dividing decimals is kind of like dividing numbers that are not decimals. And that explains why my very first example doesn't even have any decimals in it. Because I want to review how we do a division, and then we will go ahead and do divisions that involve decimals, and we'll see that we are using all of the same steps. We just have to learn a couple of new steps that go along with the stuff we already know. And I want to review these words. When you're dividing, you will say something like 64 divided by 8. Well, 64 is the dividend. 8 is the divisor. The answer we're going to get is the quotient, and we'll go up on the top right here. It's good to know the words that go with the math, because being able to explain what you're doing and how it works is part of the learning process, and in fact a very important part of the learning process, not only in math, in any type of learning you do. Okay, so how do I divide? What does that do? How does that work again? We try seeing if 8 will fit into 6. And if it will, I say, how many times will it fit into 6? And that number of times I'll write right above the 6. But 8 won't fit into 6. So that means that we have to also include this 4. We're going to say how many times does 8 fit into 64. And we know our multiplication table, so we know 8 fits into 64 8 times. Because I'm using the whole 64, which ends here, the 8, that's my answer, is going to go right here above the 4. And then I say 8 times 8, what does that give me? It gives me 64. I write that here, I subtract, I get a 0, and that means I know I am finished. The answer is 8. Of course, it was an easy one, and I expect all of the students, as soon as they saw it, realized 64 divided by 8 is equal to 8. So now we see that, yes, of course, that's true, but this is what it looks like when we do a division. Now, let's do another one that's almost the same, but we're going to start including some decimals in what we're doing. So we're going to say, how many times does 8 fit into 6.4? Aha! So my dividend is now 6.4 and not 64. But that's one extra step, simply that I just had to write the decimal in its place as I set up my question. But then we kind of ignore the decimal and we do the same stuff that we were doing here. 8 doesn't fit into 6, so I'm not going to write a number right above the 6. That means I have to look at 64. I'm ignoring the decimal. 8 does fit into 64 8 times, so I'm going to put the 8 right here. Now when I do this, the decimal in my answer is going to go right above the decimal in my dividend. Now over here we could say, well, that didn't happen here. Well, in a way it did, because 64, if you wanted to show where the decimal was, it's here. And therefore, in the answer, the decimal would be there. So 64 decimal, or 64 decimal 0, and 8 decimal 0, we know that we don't always have to write that 0. If there's nothing but a 0 to the right of the decimal, you don't have to write the 0, and in fact you don't even have to write the decimal. But you do need to know when you're learning decimals that the decimal is actually there. That's the position it would be in. So here, it was in this position, so the decimal in the answer will be right above. And I have my answer. The answer is 0.8 or 0.8. And I can verify this by multiplying, and we know how to multiply. So if I were to say, okay, what is 8 times 0.8? We set it up this way. It's a multiplication. We don't have to write a decimal under the line, not yet. And we line it up so that the last digit in each of our numbers is lined up one above the other. And then I say 8 times 8, that is 64. I write a 4, and I'm going to carry a 6. Sure, I could just write the 64 because I know I'm finished, but if I want to show it this way, okay, what is 8 times 0? It's 0 plus the 6 I carry is equal to 6. Now we do that trick to see where does the decimal go. There is one decimal digit, one digit to the right of the decimal in total for the two numbers in our question, so there has to be one decimal one digit to the right of the decimal in our answer, and we have the answer we expected. So yes, always with division, you can verify by doing a multiplication, and I will occasionally do that. What am I doing for time? Pretty good start. Of course, yes, there were easy ones. I'm going to leave this thing here, and I'm going to erase these questions and put up new questions. I'll try to fit 2 questions at a time, but sometimes I'll just put 1 question at a time because I want to write really big so that it shows up on this rectangle. Okay, erasing time. I'm erasing both of these starter examples, and I'm going to put in my next example, which is, my divisor is 5. I think I'm just going to put 1. So nice and big. My divisor is 5. And it is going to be divided into the dividend 3.55. Nice and big. Okay, so what do? We see the decimal here, so we'll put a decimal above it. And then we sort of ignore this decimal and we do the same process we would do if we were doing division without decimals. How many times does 5 fit into 3? It doesn't fit into 3. So then I say, how many times does 5 fit into 35? And that is 7 times, so I'm going to put a 7 here. And then I am going to say 5 times 7 is 35. I write that. I subtract. These cancel, and all that's left here is I can show this 0 as a placeholder. 5 minus 0 is 5. Okay, how many times does 5 fit into 5? Once. I put that right there. Notice how I'm lining the numbers up and lining the decimals up. It's important. It makes sense when you do it this way. And if you write it too sloppy and crooked, you can't really see where your numbers or your decimals are, and you get confused. But at this point, 5 times 1 is 5. I'm going to do that subtraction thing again, and when I get 0, I know I'm finished. So therefore, 0.71 or 0.71 is my answer. And it's not so bad. And it's not so different from what we were already doing before we started doing divisions with decimals. Let's do another example. Erasing time. And I have a lot of examples today because these can go by pretty quickly, and that's good because the more examples you do, the more clear it seems to the students who are just starting this and are not necessarily feeling completely comfortable with it at first. I want those students to feel comfortable by the end of the lesson. My next example, 7 is being divided into 3.01. Okay, I'm going to write a decimal right here above this decimal. I am going to say, does 7 fit into 3? No, so I'm not going to be able to write a number here. But does 7 fit into 30? Yes, 7 fits into 34 times because we can do 7 times 4 is 28. And then we do a subtraction. 10 minus 8 is 2. I did that by borrowing a 1 from this. 2 minus 2 cancels. It's equal to 0. I don't have to write it. And then I have to carry this down. So I can put the 0 placeholder there if I want, or not, but I have to bring that one down. And now I'm saying, how many times does 7 fit into 21? That is 3 times. 7 times 3 is 21. We do our subtraction, we get a 0, we know we're finished, and our answer is 0.43 or 0.43. It's not so bad. It's not really very different from saying, what is 301 divided by 7? Just that decimal is there and you just have to know how to deal with it. Otherwise, the steps are really the same. That's good. Okay, another one. What if we have more 0 placeholders? So I want to do an example like that. Again, not a very difficult one. I think some students would be able to do it in their heads. But it's the sort of question where people can make mistakes when they try to do it in their heads. It's easy to become confused with some things. So I'm going to put a 2 as my divisor, and my dividend is going to be 0.006. Make that a little longer. Okay, lots of zeros. I'm going to put a decimal right above the other decimal. 2 doesn't fit into 0. And then 0, 0. Well, 0, 0 is still 0. 2 doesn't fit into 0, 0. 2 doesn't fit into 0, 0. What happens when I realize 2 doesn't fit into this? It means I have to put a 0 placeholder. Because if I don't, when I eventually start getting answers, getting numbers, those numbers will end up too close to the decimal. This is why we line up our decimal and we have to have a procedure. And then of course 2 still doesn't fit into this part, the 0.00 part, so I need another 0 placeholder. Finally, I can say, oh yes, 2 does fit into 6 3 times. 2 times 3 is 6. Do my subtraction, I get 0, I am finished, I have my answer. 0.003 or 0.003 is the answer. And when you think about it, you probably aren't too surprised, because to verify, I multiply the divisor by the quotient and see if I get the dividend. So 2 times 0.003, not a very difficult one. I'm doing my multiplication of decimals, which I know all the students know how to do. 2 times 3 is 6. 2 times 0 is 0. 2 times 0 is 0. 2 times 0 is 0. I guess I can stop. But then, oh yes, decimal digits. 1, 2, 3. 1, 2, 3 digits to the right of my decimal. Therefore, 0.006 is my answer. And I'm not surprised. And we can see the importance of this process of counting decimal digits, because otherwise we could have said 2 times 3 is 6. Why would we bother? We're going to stop. We're not going to write any zeros, and we would think 6 was the answer. It's not the answer. 0.006 was the answer, and our knowledge of multiplication with decimals proves it. Very useful to be able to verify your answer when you do any type of math. Multiplication and division work really well together in that way. You can always verify one of them by doing the other. Next one. I'm going to start increasing the size of some of the digits and the number of digits, and I'm going to try and make it a little bit more challenging, but only a little bit at a time. So how about 6 being divided into 5.4? What do I do? I put a decimal right here. I say, does 6 fit into 5? No. So I'm not putting anything there, or I could put a 0 placeholder there. Does 6 fit into 54? Yes. 6 times 9 is 54, which we all know if we know our multiplication tables. So 9 times 6 equals 54. I subtract, I get a 0, that means I finished. 0.9 was my answer. It didn't actually get much harder, did it? Let's do another one. Okay, this one, the dividend had 2 digits, one before, one after the decimal. Let's do one where the dividend has 3 digits. Need more chalk. 2 is my divisor and is being divided into the dividend 52.6. Lots of digits now. And I want to start with the step that I know has to happen early in the process. I could wait till later to do that, but I find it confusing. I like getting the decimal into the right place right away. And then, does 2 fit into 5? Well, yes. We kept on seeing that the divisor didn't fit into the first digit of our dividend in those examples, but it's because I was giving easy ones. And now we have this one, and yes, 2 does fit into 5. So, how many times does 2 fit into 5? I can say 2 times 2 is 4, and I can subtract. And notice where I write that 2. Because 2 does fit into 5, the answer I get when I figured that out goes right above the 5. And now when I subtract, I have a 1. Now 2 doesn't fit into 1, so we need to take this one. We need to carry this down. If you want, you can write a 0 placeholder there, but you don't really have to. It's a matter of preference how we show this. And now does 2 fit into 12? Yes. 2 fits into 12 6 times. 2 times 6 is 12. I'm subtracting. I'm getting a 0, or am I? No, I'm not, because I have this. If I show some placeholders, this 6 is still, here, there. Okay. But the 1s cancel, the 2 cancels, 2's cancel, so the 6 is still there. I'm not finished. Does 2 fit into 6? Yes, 3 times. I'll put the 3 there. 2 times 3 is 6. I subtract. I get a 0. I know I'm finished because I got that 0. And 26.3 is my answer, and it's really not that hard. And of course, I can verify. 2 times 26.3 lining it up the way I line up multiplications. 2 times 3 is 6. 2 times 6 is 12, so I write the 2 and I carry a 1. 2 times 2 is 4, plus the 1 I carried is 5. I only have one decimal digit, so I need one digit to the right of the decimal, and I get 52.6, which was my dividend in the original question. The verification proved that I did it right. This is cool. So as we get a little bit more stuff going on with the numbers, our procedure still works. And that's the important thing, is to have confidence in that procedure. Let's keep on taking these baby steps. Well, actually, before I erase, I'm going to take a sip of my fizzy water. This is root beer flavored fizzy water. That's good. Okay, and don't forget, students also need sips of fizzy water or something every now and then. And students need to stretch like teachers need to stretch, especially these shoulders. Something about teaching math makes my shoulders need to be stretched a little bit and limbered up. Okay, now next question. I need to erase. Erase my verification, erase my division. Lots of examples. This time I'm going to say it the way you normally say a division. We normally will say out loud, number divided by other numbers, so I'm going to say it that way. 66.39 divided by 3. Okay, now 3 is going to fit into 6. So I realize I have a lot of stuff going on with this one, but first, before I get into that, I'm going to put this decimal right above the other decimal. 3 fits into 6 2 times. 3 times 2 is 6. If I subtract, well, that cancels. Notice how I like to draw my line all the way across, though, because I know what's happening next. The 6 minus 6 cancels, but this 6 has to be carried down. And I could carry all of this down. But I'm really looking just at this 6 right now. Does 3 fit into 6? Yes, we know 3 fits into 6 2 times. Notice where I'm writing this second 2, right above that. 3 times 2 is 6. I subtract. I can show my 0 placeholders or I cannot. I think this time I'm choosing not to show them. These cancel, but the 3 and the 9 get carried down. Now, does 3 fit into 3? Yes. 3 times 1 is 3, so I have to put a 1 right here above that 3. 3 times 1 is 3. I subtract. This is going pretty far. I hope it doesn't go right off the bottom of the screen in the rectangle. 3 minus 3 cancels, but the 9 gets carried down. I'm getting close to the bottom. How many times does 3 fit into 9? 3 times. These are some of the easier multiplications in our multiplication table, aren't they? The 3's. 3 times 3 is 9, so I write a 9 here. I subtract, I get a 0. That means I know I'm finished, and oh, it just barely fit. That's good. Okay, so if I do any that are much more complicated than this, I might have to start writing smaller to try to make them fit. But it works, and I like it that it works. It just feels good. Okay, verification though. 3 times 22.13. Lining them up the way we line up multiplications, not trying to put a decimal in here. 3 times 3, that's 9. 3 times 1, that's 3. 3 times 2, that's 6. 3 times 2, that's 6. How many decimal digits? 1, 2 decimal digits, so 66.39 is my answer, and that's what I expected. The verification makes me feel good about my answer. How about another one? How about another one? How about another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 more. I'm looking how I'm doing for time. A couple of examples where I'll want to slow down a little bit. How about erasing all the way down there. Okay. How about 9 into 6.48? Okay, so now it's a 9. And a 9 is not going to fit into a 6, so I see a little bit more stuff going on that way. Decimals here, decimals there. 9 doesn't fit into 6, so I'm not putting a number there, or I could write a 0. But 9 does fit into 64. How many times? 9 times 7 is 63. 9 times 7 is 63. Subtract. That leaves a 1 here, but this 8 has to be carried. Does 9 fit into 1? No. But does 9 fit into 18? Yes, twice. 9 times 2 is 18. Subtract, I've got a 0, I know I'm finished. 0.72 is my answer. I'm not going to verify it this time. I'm going to move on to another example. This is fun. Lots of erasing going on. 8 into 3.616. Decimal right above other decimal. Does 8 fit into 3? No, so I'm not writing anything here, or I can put a 0. I think this time I'm going to show the 0. Does 8 fit into 36? Yes. 8 times 4 is 32. Subtract, the 3's cancel, 6 minus 2 is 4, and the 1 and the 6 carry down. Does 8 fit into 41? Yes. 8 times 5 is 40. I subtract, these cancel, 1 minus 0 is 1, the 6 carries down. Does 8 fit into 16? Oh yes. 8 times 2 is 16. I write the 2 there, I multiply, I do my subtraction, I get a 0, I know I'm finished. 0.452 is my answer, and I'm quite satisfied with that. Let's do another one. It's interesting how useful the things you already know in math are when you're learning something new in math. What are we doing here? We're doing division like we already knew how to do, except now there are some decimals there. And we're verifying by doing multiplication. But to verify a multiplication, to verify with multiplication, a division that was done with decimals, you have to be able to multiply with decimals. But we've been working on that for, I think, the last 3 lessons. So we know how to multiply with decimals. We're using all of the stuff we already know as a structure that keeps us stable as we work our way through this new knowledge. And we add just a little bit of new knowledge at a time. 5 into 0.725. Put the decimal right above the decimal. 5 doesn't fit into 0, so I'm not going to write anything here, or I could write a 0 there. 5 fits into 7 though, once. 5 times 1 is 5. Let's subtract. 7 minus 5 is 2, but I'm going to carry down this 2 and this 5. 5 doesn't fit into 2, but it fits into 22. 5 times 4 is 20. Subtract. These cancel. 2 minus 0 is 2, and the 5 gets carried down. And 5 fits beautifully into 25. 5 times 5 is 25. Subtract. Get a 0. I know I'm done. 0.145 is my answer. I feel good about it. It's just I really want to think about how we're placing everything. With the way the decimal goes right above the other decimal is what's making this work. The way that I'm making sure that I don't squish the numbers together on one line and have them written further apart on another line, so you can see which numbers are above which other numbers as you go through this whole process. I think the fact that I'm doing it neatly is the main reason why I don't feel like I have to put a bunch of 0 placeholders in here. But we can put 0 placeholders in there if we want. Interesting what we're doing. Next one. And we're getting into some rather large numbers. Well, it's a decimal, so it's small and it's large at the same time this time, because 0.725 is less than 1. So it's a small number, which is also a large number in the sense that it has a lot of digits and there's complexity to it. We can handle that complexity because we can handle decimals. Okay. Next example. 7 is being divided into 0.0364. Lots of digits, placeholder zeros. Put the decimal right above. 7 doesn't fit into 0. And 7 doesn't fit into 00. And in fact, 7 doesn't fit into 003. So I need to start showing some placeholder zeros or I'm going to get confused. Since 7 doesn't fit into 0, 0, I'm going to put a 0 here. And since 7 doesn't fit into 0, 0, 3, I'm going to put a 0 here above the 3. But 7 does fit into 36. 7 times 5 is 35. And when I subtract, these cancel. 6 minus 5 is 1, and then the 4 gets carried down, so I have a 14. 7 fits into 14 2 times. 7 times 2 is 14. Subtract, get a 0, you know you're done. Will we always get a 0 like that? No. We're still doing some sort of beginner decimals. Sometimes this kind of can continue on. And I'm going to get into some examples a little later where I'll let it continue a little further to see, well, what happens if it's not so convenient? What happens if you don't get this fraction that perfectly gives you a 0? What do you do then? Well, there are things that we can do. We have control. We are mathematicians. Okay, 0.0052, that is my answer. I like my answer. I'm not going to verify this time. Let's do another one. 6 is my divisor, and it's going to be divided into the dividend 0.3, what else is there, 618. Let me make sure I copied that correctly. Lots of digits. Okay, so what do? I have a procedure. Decimal right here. 6 doesn't fit into 0, so I don't have to write anything there, or I can write a 0 there. 6 doesn't fit into 3. So I'm going to need another placeholder 0 in my quotient. But yes, 6 fits lovely way into 36. 6 times 6 is 36, so I can put a 6. I've got a 36. I subtract, I'm going to get a 0, I'm finished. No. No, the 18 is still there. Not finished. 3 minus 3 cancels, 6 minus 6 cancels, but the 1 and the 8 get carried down. Does 6 fit into 1? No. So I need another placeholder 0. Well, that's interesting. That hadn't happened in my previous examples, but the process still works because I know 6 doesn't fit into 1. I have to put a 0 there. Does 6 fit into 18 though? Yes, 3 times. It's lovely the way 6 times 3 happens to be exactly 18. We are still getting these convenient subtractions at the end where we get a 0 and we know we're finished. 0.0603. Who would have thought that this number with all these zeros would be the answer when my dividend was 0.3618, didn't have any zeros except over here to the left of the decimal. So you don't necessarily get to look at a question and immediately know what the answer is going to be, although we do have a feel for that. And we could sort of try to do it. But when the question's complicated and you can't just look at it and know the answer, the process still works. Can we prove that this process still works? Do we feel confidence? If I'm looking at this and thinking, wait, no, there's too many zeros here, I don't know if I trust it. I have something I can do. I have my verification, and I'm going to do that. 6 times 0.0603 must give 0.3618 as the answer if I did this correctly. So let's do a multiplication. 6 times 0.0603. I didn't line that up very well, so I'm going to rewrite that 6 so that it lines up nicely, because I am not trying to line it up the way you line up in addition. I'm trying to line it up the way you line up in multiplication. Okay, and I'm not writing a decimal down here. I can't do that yet when I'm multiplying. 6 times 3, that's 18. I can write the 8 and I can carry the 1. 6 times 0 is 0, plus the 1 I carried is 1. I write that. I didn't have to carry anything this time. 6 times 6 is 36. I write the 6 and I carry the 3. 6 times 0 is 0 again, plus the 3 I carried is 3. And at that point I'm finished because I have nothing but zeros. I have gotten to the end, except I'm not finished. I have to show my decimal digits and figure out where the decimal goes in the answer. 1, 2, 3, 4 decimal digits in total in these two numbers. So I need 1, 2, 3, 4 decimal digits. That means my answer is 0.3618, or if I want 0.3618. Oh look, now I feel confident that I was doing this correctly. Even though I needed those placeholder zeros, I got it. And I trust it because I trust the process. How am I doing for time now? Pretty good, pretty good. That brings up an interesting question, and I meant to leave more room so I could do another one. So what I'm going to do is I'm going to erase my verification because I think we all know that that is now verified. Because I don't want to erase this. I like it. But what if I were doing, and I'm going to have to be careful not to run out of room, so I'll write a little bit smaller. What if we were just going 6 being divided into 3,618? Kind of similar. But there's a major difference here. What would happen if this was just the old-fashioned division from before we had to do decimals? Because we know we've been doing a lot of tricks like this where you realize that where the decimal is in the number has a lot to do with whether you're multiplying by 10 or 100 or 1,000 or dividing by 10 or 100 or 1,000. So this is like the same number as this, except the decimal's in a different place. In this one, the decimal's way over here, and we don't even have to write it. Let's do this division. 6 doesn't fit into 3, so I can't put a number here. But 6 does fit into 36 6 times. 6 times 6 is 36. I'll subtract. Well, but when I subtract, all I get is this 18. 6 doesn't fit into 1, so I have to put a 0 placeholder there. But 6 fits into 18 3 times. 6 times 3 is 18. I subtract. I get 0. It's interesting how that went sort of quickly. But it really looks like the same thing. It's like the same mold with different problems that have different answers because the decimal's in a different place. But look at that. 3-digit answer, 603. The quotient is 603. Whereas here the quotient was 0.0603. We needed that 0 there, here, because of where the decimal was. But in this one, remember where my decimals are. They're actually there. So I don't need a 0 placeholder there. I mean, I could write a 0 if I want, but I don't need one. So the answer is 603. Let's do that verification. 6 times 3 is 18, write the 8, carry the 1. 6 times 0 is 0, plus the 1 I carried, write the 1. 6 times 6 is 36, write the 6. I carry the 3, I don't have to because I got to the end, so 36, 18, yeah, works. Interesting. I like comparing these two questions. It gives me insight. It makes me think about these placeholder zeros and the position of the decimal and how important that is when you're doing decimals. I like it because the questions aren't hard, because we're able to focus instead of on hard decimal division questions. We're able to focus on just the thing we're learning, which is how do we do this process that we already know when there's a decimal involved? What does it mean? I like this. Okay, next example. Oh, okay. I'm moving on to a slightly different type of question. And again, baby steps. So we're going to start with a nice, simple, easy one. One that we could have done before we ever learned anything about decimals. And back to that sort of easy intro question, background material question, review question. But I have a reason to do it. I have a plan. Bit more chalk, bit of a stretch. Fizzy water. Where I live, it is about 10 after 4 in the afternoon, and it's getting dark. It's not dark, it's getting dark. If you were throwing a football, you'd still be able to see the football quite well. Or if you were throwing a frisbee. So it's not dark, it's getting dark. 10 after 4. Whew. Okay, winter is coming. What's my next question? Oh yeah, nice easy one. We're going to do 2 into 48. No decimals at all. Why? Because I want to compare it to another question that I'm going to do right next to it. But I'm not telling you that whole question yet. Okay, exercising our old division muscles that we already had before this lesson started. 2 does fit into 4 2 times. 2 times 2 is 4, subtract, 4 minus 4 cancels, but the 8 gets carried down. 2 fits into 8 exactly 4 times. 2 times 4 is 8, I subtract, I get a 0, so I know I'm finished. Simple. Of course it's simple. And we expected it, because even though 48's 24s aren't really in the multiplication tables that most people memorize. 2s are kind of easy. So I think a lot of students looked at this and thought, oh, 48 divided by 2, well, of course that's going to be 24. They'd have a feeling for it. So we're not surprised to get this answer. How about this one? Did I leave enough room? Yes. Just barely. Okay. Same procedure. Does 2 fit into 4? Yes. 2 times. 2 times 2 is 4. Subtract. These cancel. The 9 gets carried down. Does 2 fit into 9? Yes. 4 times. So far it's the same. 2 times 4 is 8. Oh, here's where it's different. Because 9 minus 8 doesn't cancel. It leaves a 1. I didn't get a 0. So what do? If I were just doing division without decimals, the way we've learned in the past, I would say 1 is my remainder. So 49 divided by 2 is equal to 24 with a remainder of 1. Nothing wrong with that. That's true. It is a true mathematics answer. But now that we know how to handle decimals, there's something else we can do with this question. We knew that there was a decimal here in the 49. And therefore there's a decimal here in my quotient. And I can keep going. Because I can write a 0 here. And therefore, when I carry down, I can have a 0 here. I can write a lot of placeholder zeros in between. But this is what I've been doing in the other examples. I can do that. And now it's a 10. And 2 does fit into 10, a beautiful 5 times. 2 times 5 is 10. We subtract, we get 0, we know we're finished. 24.5 is the answer. So we don't have to stop and say a remainder. Once we know how to use division with decimals, we're able to continue and get, I guess, a more accurate answer? No, I don't want to say that. 49 divided by 2 is equal to 24 with a remainder 5 was an accurate answer. But 24.5 is also an accurate answer that uses decimals. So I think we need to do a couple more like this to see what happens when you're able to keep going in a way that you weren't able to before, because now you know how to do the decimals. Erase, 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 erase. That was interesting though. Such easy looking questions, but there's so much insight to be gained from them. How about 8? I'm writing big because I'm only going to put 1 at a time right now. 8 into 43. You notice how I made this line longer than I needed it. But I'm not going to erase because maybe I am going to need there a little bit more over there. Where's my decimal? It's here. So therefore there's a decimal right here above it. 8 does not fit into 4, so I either write a 0 there or I don't write anything. 8 does fit into 43. 8 times 5 is 40. I subtract. 3 minus 0 is 3. The 4's cancel. 8 doesn't fit into 3, but if I want, I can put a 0 here and I can carry it down because 8 does fit into 30. 8 times 3 is 24. I subtract. 3 minus 2 is 1. No, that's not how I subtract. 10 minus 4 is 6. And I did that by borrowing a 1 from the 3, which turned the 3 into a 2, and therefore I have a 10. 10 minus 4 is 6. I have to try and remember how I explained how to do a subtraction. Okay, 10 minus 4 is 6, and then 2 minus 2 cancels, so I just have a 6. Does 8 fit into 6? What is this going to go on forever? I'm worried that it might go on forever. Maybe I should have written smaller, because if I keep on going down all the way to the floor, I might have to tilt the camera. I'll start writing smaller to see if I can fit it. Okay, so 8 doesn't fit into 6, so what I'm going to do is I'm going to put another 0 here, make these lines longer, carry that 0 down because 8 fits into 60. So now it's going to be perfect, and I'm going to subtract and get a 0, right? No. 8 fits into 60 7 times. And I have to be really careful where I'm placing the numbers. It can get messy, and this is a little messy. But if I'm careful not to be messy, then it's easier to keep track of everything. 7 times 8 is 56. And yes, I am writing smaller because I want this to fit. When I subtract 10 minus 6 is 4. I did that by borrowing. So 5 minus 5 cancels. And again, 8 doesn't fit into 4, so if I want to keep going, I have to take another 0. Which carries all the way down to here. Ah, now things are going to clean up, because 8 fits into 40 perfectly 5 times. 5. 5 times 8 is 40. Will this fit? 40. Subtract. Get that 0. Did that fit? Yes, it did. Woo! Okay, this camera angle is being very forgiving with me. So that means I'm finished. 5.375 is my answer. That's crazy. That would seem to just go on and on and on. Would it go on and on forever? Could it go on and on forever? And if it goes on and on forever, what do we do? How do we know when to stop? The interesting thing is, the only reason we're asking ourselves this question is because we have learned a procedure of dividing with decimals, and that procedure is so powerful that instead of getting lost somewhere along here, I just kept applying my procedure and I got an answer. I like that. And I could try to use rounding. I could say, well, this is quite close to 5.4. So I know my answer is close to 5.4, but I'm able to be more exact. So sometimes rounding is a good way to give an answer, but sometimes you want to go a little further and give a more accurate answer. Now, I don't have to round to give my answer. This is the correct exact answer because of the fact that I got that 0 there when I subtracted. This is cool. I think this one, though, justifies a verification multiplication. So I'm going to do that. And the last thing I'll be able to do before I have to get rid of this piece of chalk. Okay, how do I verify? Why am I holding this? I'm going to put it down. I am going to say 8 times 5.375. Can I fit that here? 5.375. Lining up the last digits of my numbers like I do with a multiplication. Okay, not trying to put a decimal down here. It's multiplication. 8 times 5 is 40, so I put a 0, and I carry a 4. 8 times 7 is 56 plus the 4 I carried, so that's 60. 56 plus 4 is 60, so I'm putting a 0 and I'm carrying again a 6. 8 times 3 is 24, plus the 6 I carried is 30, so I'm writing a 0 again. I'm carrying a 3. Whew. 8 times 5 is 40, plus the 3 I carried is 43, and I'm able to write the whole thing because I got to the end. I still have to do my decimal digits. There are 1, 2, 3 decimal digits, so I need 1, 2, 3 digits to the right of the decimal. Interesting. My answer is 43.000. But of course, we know that 43.000 could be just written as 43. What did we start with? We started with 43 divided by 8. These 000 occurred as part of the process that we had to do because this subtraction thing kept on going on, not forever. I like it. 8 times 5.375 is indeed 43. Feel like grabbing a calculator and saying, wait, 8 times 5.375 equals, and will it give me 43? I know it will. I don't need the calculator. That's one of the cool things about understanding math, is realizing that you don't need a calculator. Okay, I'm not finished. I have a couple more examples, and I have a bit more time. I do need a bit of fizzy water, though. Finished that. Okay, what's my next example? What if it does go on forever? Let's see if I can make one happen where it's going on forever. What does that mean? Do we even trust it? When it seems to be going on forever, does it mean it really is? This is something that happens when you start learning about decimals. Decimals have a lot of interesting complexity. So I'll erase this verification multiplication, and I'll erase my division, and I'm going to put in another answer. And of course, since it's going to go on and on and on, it has to be an extremely confusing looking question, doesn't it? No, that's too high. I don't want my quotient to bump into this line here. So a little lower, but I am writing a little bit smaller just in case I have lots of steps. So it's 9 Oh, okay. It said that was the last question with that piece of chalk, and I was right. And then I stepped on the chalk. Okay, fortunately, I have more chalk right here. Okay, let's get that adjusted. 9 is being divided into 1. So why did he draw the line so long? Just in case. So where's the decimal if I have 1? The decimal's right here. Therefore, I want to put the decimal right above it up here. And 9 does not fit into 1. So I can write a 0 or not write a 0. I'm choosing to write the 0 this time. So that's why I need to be able to put a 0 here. Now I know that 1 is equal to 1.0. Or 1.000 or 1.00000. Well, you can put as many zeros as you want on the right side of that decimal. We've talked a little bit about that. There's something written, but it's, I'm thinking of something I had written on last week's lesson plan, which means I know I've covered this. That's good. Okay, does 9 fit into 10? Yes. And I'm not going to write all my ones pretty like this. I'm just going to put this type of 1. Okay, 9 times 1 is 9. Make the line go all the way across. 10 minus 9, well, 10 minus 9 is 1. So I'm switching over to this type of 1. Okay, but that would be my remainder, I guess. No, we're not doing that anymore. We're doing dividing of decimals, so we keep going. Will we go on forever? We can't go on forever. So we'll keep going until we realize there's a reason to stop. How about that? Okay. So 10 minus 9 is 1. I need another 0 here, which means I'm putting another 0 there. I can write placeholder zeros all over the place. Okay, 9 fits into 10, 1 time. So therefore 9 times 1 is 9, subtract. It happened again. 10 minus 9 is 1. Oh, I'm starting to see a pattern emerge. I'm starting to get an idea of what's happening here. Because if it happened twice, does that mean it has to keep happening? So I'm going to put another 0, and therefore I can put another 0 here. It's hard to line this up, especially when I'm standing to the side of it like that. It's a good idea to do this when you're doing dividing decimals like this, especially when they get complicated. It's a good idea to use lined paper, graph paper, so that you can use the lines to help you keep all the numbers lined up so that you don't get confused. Okay, 9 fits into 10, 1 time. We're not surprised anymore, are we? We're putting a 9 here, we're subtracting, and we're getting a 1 again. Okay, so we could do this forever. Because what's going to keep on happening is every time I subtract, I'm going to get a 1. And then when I put a 0 beside that 1, I'm going to get a 10. And 9 fits into 10 1 time, so I'm going to write another 1. So I'm getting this number, 0.111. It is going on forever. I'll do 1 more, okay? 9 fits into 10 1 time. Did I write that? Let me see. 1, 2, 3. This is the 4th time. I need another 1. I need another 0. Yes, I need another 0 here. I need another 1 up there. And then when I subtract, it happens again. I have to stop. Eventually, I have to stop. So I haven't done a decimal. 0.1111111111. I can predict that it's going to keep on being 0.111111, as many ones as you want. We don't want to write that number down. Because if it's going to keep on being 1s forever, well then we would be writing forever. So we have this number which either we have to round it or we have to find another way to express it. There's a trick which I don't know if the students in this lesson need to do, but the trick that when you have this happen, you look for the pattern, you look for what repeats, and what's repeating is simple patterns, 1. 1 keeps repeating, so you write that 1 and then you put a line over it. It means 0.1 repeating. And that means this happened. And it allows us to write the number and not have to be writing forever. Or we round. We can round this, and if we know our rounding tricks, we know that this is going to round. It's kind of an easy one to round because we're not going to have to bump it up. 1 always rounds down. So we could say the answer is 0.11 if I want it rounded to the nearest hundredth, or 0.111 if I want it rounded to the nearest thousandth, or just 0.1 if I want it rounded to the nearest tenth. Interesting. So this happens with decimals. It can happen with decimals. where you get a pattern that repeats. I think we need to do another one. What's my next one? And I see what's coming as far as my lesson plan. I only have 2 more questions. But because this kind of got a little bit crazy, it took a little more time than some of the examples we were doing before. So I only have 2 more examples, and I don't want to rush them because I don't want this to confuse people. I want it to delight people. I want students to feel the way I do about this because I think this is cool. It's so neat. So let's try another one where we'll get decimals that go on and we have to decide what to do. 7 divided into 22. And again, I'm making my line long just in case. Where is my decimal? It's here. So therefore there's a decimal there. 7 does not fit into 2, so I do not have to write anything here. But 7 fits into 22 3 times. 7 times 3 is 21. Subtract. These cancel. 2 minus 1 is 1. 7 doesn't fit into 1, so I need to put a 0 there, showing a 0. And that means that 0 carries down, and 7 does fit into 10 1 time. Okay, got another 1 after the decimal. Is it always going to be a 1? Kept on being 1s in the last example. Let's go a little further and see. 7 fits into 10 1 time. 7 times 1 is 7. When I subtract, nope. 10 minus 7 is 3. It's not another 1. So I'm not getting just 1s. It's not always going to be 1s. But I can keep going. 7 doesn't fit into 3, so I'm going to put a 0 there, and that 0 carries down here. And 7 fits into 30 4 times. 7 times 4 is 28. Subtract. 30 minus 28 is 2. Still not finished. This could go on for a while. Not sure. Sometimes you want to carry on for a few more steps just to see if it's going to keep on going, or if it's going to get to that subtraction giving 0 thing where you know you're at the end and you have an exact answer. But eventually, you might decide to just round. Okay, 2 doesn't work. I need a 0, which means I need a 0. 7 fits into 20 only twice. 2 times 7 is 14. I think what I'm going to do is I'm going to let the fact that I'm going off of the screen of the video tell me when to stop. 20 minus 14 is 6. 7 doesn't fit perfectly into 6, so it will keep on happening. So if I'm going to round it, if I decide to round to the nearest hundredth, I could say my answer is 3.14 to the nearest hundredth. I could round it to the nearest tenth and say the answer is 3.1. I could round it to the nearest unit and say the answer is 3. But I like having more exactness in my answer. So the only reason I don't want to say 3.142 is the answer is because I don't know if that 2 would stay a 2 or if it would round up to a 3. To know that, I would have to go a little further. So I've gone far enough so that I decide to round to the hundredth, and I feel confident 3.14 is the correct answer if rounded to the nearest hundredth. Sometimes when you're dividing decimals, you can get this going on and on and on thing, but the good news is that you're able to use rounding so that you're still able to give an answer that you can write down. Kind of interesting. And like I said, I do have one more example. And it's to go into something else that's just starting this week. We'll probably do more of it next week. But we've had enough with this going on forever stuff. I think I've introduced that topic to a great enough degree. I want students to practice a lot. Okay. Students have probably been asking this the whole time. But when will we get one where the divisor has a decimal in it? We keep on getting questions where the dividend has a decimal, but the divisor keeps on being a whole number. What if the divisor has a decimal? Well, this is a very much a good news thing. Okay, I'm going to do one. 0.3 is my divisor, and it is being divided into the dividend 0.21. And at this point, I'm going to erase this very handy little diagram because I think I'm going to want some room over there. What do I do? It's confusing. It threatens to be confusing. We're not going to let this confuse us. If we ignore the decimals, we're saying how many times does 3 fit into 0? How many times does 3 fit? Notice how it's not confusing, it's not hard. We've been doing it with so many examples. We know what to do. Why am I holding this? I'm putting it down. Okay. But that, how many times does 0.3 fit into? It starts getting a little confusing. Because when you do this thing that we're doing, when we say how many times does 3 fit into something, it doesn't involve the decimals. Remember, we're ignoring that decimal. But how many times does 0.3 fit into something? We can't really avoid that decimal. Can't really ignore it. So what can we do? What we can do works because of something that we already know, which is we can multiply 0.3. Remember multiplying of decimals? Yes, we've done quite a lot of it. And so some of the easier examples we've done are the ones where we say, let's multiply a decimal by 10 or by 100. And that's handy right now. We need that right now. When we multiply 0.3 by 10, if you'll remember, it's as if the decimal jumps one place to the right. 0.3 times 10 is equal to 3. And of course, I could put a decimal there. See, the decimal is to the left of the 3, but because I multiplied by 10, it jumped over here, and now it's to the right of the 3, where I don't really have to write it. Therefore, I can turn 0.3 into a 3 if I want. And I do want to. I want to divide by 3 because this thing where the decimal is there was confusing, but if I do this instead, it's not confusing. But there is one other thing we have to do to take care of this. If we're going to multiply the, and there I am needing the words. If we're going to multiply the, divisor by 10, we're only allowed to do that if we also multiply the dividend by 10. So 0.21 has to also be multiplied by 10. But again, multiplying a decimal by 10 isn't very hard. It's kind of fun, actually. We're moving the decimal one space to the right. We're jumping the decimal over like this. So it's going to be 2.1. So therefore, if I want to divide by 3 instead as my divisor, then I have to divide into 2.1 instead as my dividend. I have adjusted this question to turn it into this question, because by doing that, doing something simple that I already knew how to do, just remembering to do it to both numbers, I easily put myself into a position to do something that we've been doing for this whole lesson. There's no decimal in here to confuse us anymore. We know how to do this. Put a decimal right above there. 3 doesn't fit into 2, so I either don't write anything or I write a 0. 3 fits into 21 a beautiful 7 times. 7 times 3 is 21. I subtract. I get 0. I know I'm finished. 0.7 is my answer. Therefore, 0.7 should also be the answer to this. Is it? Let's verify. Let's try multiplying 0.3 by 0.7 and seeing if we get 0.21. 0.3 times 0.7, not lining up the decimals, lining up the last digits. Remember, it's a multiplication. Okay, not putting a decimal underneath. 3 times 7 is 21. I write the 1 and I carry the 2. 3 times 0 is 0 plus 2 is 2, and I got to the end. But decimal digits, 1, 2, 1, 2, 0.21 is my answer. It worked. I didn't even verify this. I verified this original question because I have trusted that this adjustment converted this original question into this easier to do but equivalent question. It's really the same question in a way. And the verification proves that it works. I like that. What am I doing for time? I have enough time to verify this one as well, so I'm going to. Where should I do it? I'll do it here. Okay, to verify this one, that's 3 times 0.7. Okay, this time the decimals aren't lining up, but the last digits are, which is what I want for a multiplication. Should have put a multiplication symbol here as well. Okay, 3 times 7 is 21. There's the 1, carried the 2. 3 times 0 is 0, plus the 2 I carried is 21. How many decimal digits? 1. Therefore, I need 1 digit to the right of the decimal here, so I get 2.1. Yep. Interesting. it's a cool procedure. Get a division where you have a decimal here in the divisor. Why can't I remember which word is which? I just don't want to say it wrong. I probably would have gotten it right. What do you do when you get a decimal in your divisor? You do this multiplying by 10 thing, or multiplying by 100, until you turn it into one of these ones where your divisor doesn't have a decimal in it, and then you proceed with the procedure you already know, and it works. This is interesting. The power that we have when we learn how to deal with decimals is considerable. With that, I am going to say thank you because my time is up. And my beautiful assistant Mocha, who is working very hard as a heating pad upstairs, also says thank you. We are looking forward to next lesson when we get to do some more of this. Who would have thought dividing decimals would be this much fun? I did. Goodbye.